This video covers three different kinds of collisions. There are elastic collisions, which occur when there is no loss of kinetic energy. When no kinetic energy is lost, we know that the initial kinetic energy of the system will equal the final kinetic energy of the system. A basic example of an elastic collision would be two masses of equal mass collide with one another, and after the collision they are traveling in the same speed but opposite directions. So we can easily see here that the equation 1/2 mv squared would equal the same before and after the collision. Inelastic collisions occur when the initial kinetic energy of the system does not equal the final kinetic energy. Typically, this means that some energy or kinetic energy was lost during the collision. An example of an inelastic collision would be two masses collide, and when they collide, some of their kinetic energy is converted into sound and thermal energy. The last kind of collision is a totally inelastic collision, and yes, this is a formal physics term. This kind of collision occurs when there is a loss of kinetic energy and the objects stick together, much like this example, or when two football players tackle one another. Here is a condensed table that describes the different kinds of collisions. We will use this table for the following two problems. The first problem is a 2 kilogram ball is traveling east at 10 meters per second and collides with the 7 kilogram ball traveling west at 3 meters per second. After the collision, the 2 kilogram mass travels west at 10.2 meters per second and the 7 kilogram mass travels east at 2.78 meters per second. And we want to know what kind of collision this is. So to solve this problem, we must first calculate the initial kinetic energy of the system, which means we will add up the kinetic energies of both of the balls. And we find that the total kinetic energy is 131 joules before the collision. Now we must solve for the total kinetic energy after the collision, so we can fill in the values that we were given, and we see that the total kinetic energy after the collision also equals 131 joules. So since the kinetic energy of the system before and after the collision are equal, we know that this must be an elastic collision. Let's do another example. A 0.05 kilogram hockey puck travels at 5.5 meters per second as it collides with a stationary 1 kilogram water bottle. After the collision, the puck rebounds at 3 meters per second. What is the water bottle's velocity, and what kind of collision is this? So first we must calculate the final velocity of the water bottle. Since there are no external forces acting on the system, we can assume that the total linear momentum in the system is conserved. So we can fill out our conservation of momentum equation, and we can solve for our unknown velocity, which ends up being 0.42 meters per second. So we know that after the collision, the water bottle travels at 0.42 meters per second. Now we can calculate the initial and final kinetic energies of the system to decide what kind of collision this is. So, since the puck is the only object that's originally moving, we see that the system has an initial kinetic energy of 0.76 joules. After the collision, we see that there is a total energy of 0.31 joules. So therefore, we see that the initial and final kinetic energies do not equal one another. So there must have been energy converted into thermal and sound energy during this collision. This also means that since the kinetic energy is lost, this is an inelastic collision.